adding and subtracting rational numbers without a common denominator. How can you evaluate the expression 4 over 5 plus 1 over 3? Well, if I think about it, 4/5 is a shape, or can be thought of as a shape, with 5 pieces inside where 4 are shaded. I could take the same size shape and split it into 3 pieces to do 1/3. But the shaded pieces don't look the same. So if I did a quick representation, these shapes are roughly the same size, but that piece that represents a third does not look anything like the 4/5 piece. So what could I do? Well, I've got 5 pieces in one and 3 in the other. So let's make this one with 5. If I make 3 pieces in each of them, and if I take this and turn each one of them into 5 pieces, of course this is pretty messy because I'm not very good at drawing in here. I look and I see my 4/5. Really, each of my 5ths turned into 3 pieces. So I had 12 pieces that were shaded, and a total of 15 pieces. Okay, and then the 1/3, we had the 1 piece right here became 5/15. And we can just add them together to do the 12 plus 5 is 17, and we keep the denominator. So the only difference between what we did with adding without a common denominator, adding with a common denominator and adding without is we had to create a common denominator by looking at the least common multiple. So the same as always, we're going to change all mixed numbers to improper fractions. We're going to write all fractions with a common denominator using the least common multiple. We're going to add the numerators. We're going to keep the denominator, and we're going to reduce to lowest terms. We look at the following expressions, -2/5 plus 4/3. The least common multiple, we're going to write multiples of 3, which are 3, 6, 9, 12, and 15, and we could keep going. Multiples of 5 are 5, 10, and 15. The first one they have in common is the 15. So we can look at this, and we're going to change this 5 up here into a 15 by multiplying it by 3. And if we multiply the 5 by 3, we also have to multiply the -2 by 3. And you can see that step occurring right here in this first line of the solution. The denominator in 4/3 has to be multiplied by 5. If you multiply the denominator by 5, you must also do the numerator, which you see right here. So when I have -2 times 3 plus 4 times 5, I can write it all in the numerator of the next line because they're going to have the same denominator. So -2 times 3 is -6, 4 times 5 is 20, and -6 plus 20 gives me 14 over 15. When I look at 2/5 and 3/4, I need to look at my denominators again. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. Multiples of 4, 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and I see that the first one that's common to both of them is this 20. And the 5 had to be multiplied by 4 to get 20, and the 4 needed to be multiplied by 5 to get 20. So we're going to take this fraction here, the 2/5, and we have to multiply the denominator by 4 in order to get 20. And if we multiply the denominator by 4, we must also multiply the numerator by 4. And with this 3/4, the 4 needs to be multiplied by 5 to get a common denominator of 20. And if we multiply the denominator by 5, the numerator also is multiplied by 5. Now we can multiply. 2 times 4 is 8. 3 times 5 is 15. And we can put them all over the same denominator of 20. And 8 take away 15 is 20. What strategy do we use to find the least common denominator? Remember, we could write all the numbers out. We could also, if you look at your denominator here, your denominator was 20. How does that relate to the 5 and the 4? Here your denominator is 15. How does that relate to the 5 and 3? We could actually multiply them. Will it always work? Yes, it's always going to work. But having said that, look at this one here. 10 and 8, the least common denominator, is actually 40, which is not 10 times 8. Okay, so you want to be careful. That's why we use the least common multiple, because if we didn't use the least common multiple, we would have to reduce larger numbers and work with larger digits throughout the problem. Same question here, 3/10. To turn 10 to a 40, we have to multiply by 4. We multiply it by 4, we multiply the one up top by 4. To turn the 8 into a 40, we need to multiply by 5, and if we multiply the denominator by 5, the numerator also must be multiplied by 5. So 3 times 4 gives me 12, 3 times 5 gives me 15, so if I look over here in the box to the right, it's showing the solution. 12 take away 15 over 40 leaves me -3 over 40. Is it any different when we have mixed numbers? No. But we do have to add the step of changing it to an improper fraction. So remember, the 3 wholes we have here, we have to figure out how many pieces. 3 wholes with 3 pieces in each is a total of 9, or 3 times 3. And we have to add the 2. 1 whole with 4 pieces is 1 times 4 pieces, plus 3 for the 7. Now, when we add that, we get -11 over 3 plus 7 over 4. The least common multiple, if I'm doing my multiples of 3 and 4, 3, 6, 9, 12, 15, and so on. For 4, we have 4, 8, 12. Oh, wait a minute. 12 is the same for both of them. I have to multiply the 3 by 4, which means the 11 also gets multiplied by 4. The 4 in the denominator needs to be multiplied by 3, which means the 7 is also multiplied by 3. 11 times 4 is 44, and 7 times 3 is 21, and the denominator is the same, so we write that all over one denominator. And the first fraction was negative, so we need to keep the negative sign in front of the 44, and we have to do -44 plus 21. There were 23 more negatives, so your answer is -23 over 12.